Hello math students, this is Dr. John, your physics and math professor, helping to make the complicated, which is trig identities, just a little bit simpler. I've written another trig identity up here. 1 minus cos theta over sine squared theta is equal to 1 over 1 plus cos theta. Anytime you see this, sine squared, cos squared, always be thinking maybe that's going to be Pythagoras' theorem. For these ones that I have in this section, we're going to be using trig identities, double angle, Pythagoras, and difference of squares to help solve them. In this case, you look at this and you say, that looks like Pythagoras' theorem. Let's take a look at what that would be. Sine squared plus cos squared is equal to 1. Solving this would make the sine squared equals 1 minus cos squared. So I could rewrite this one down here as 1 minus cos squared. Here on this side of the board here, I've rewritten this left side of this. The left-hand side of this. 1 minus cos theta over this. And remember, we had this relationship here. So I'm going to take that to the bottom. So I'm 1 minus cos theta, that's the top, all over 1 minus cos squared theta. This here again looks like the difference of squares. That's one of the things that we're going to be using for these relationships here. Remember, the difference of squares is a squared minus b squared is a plus b, a minus b. In this case, a is 1, b is cos theta. So I could represent this as 1 plus cos theta, 1 minus cos theta, brackets, brackets. This here, I've just rewritten the denominator here. Notice we have this here and this here. So rewriting this whole thing, I'm going to do this over on this side over here. This becomes 1 over 1 plus cos theta. This is what I'm left with here. On the top, I'm just left with a 1 because we've canceled everything else. 1 over 1 plus cos theta is exactly what this is. We've just proved this trig identity. If this was helpful, like this video, and we will see you on the next one. Bye-bye.